And hi, everyone. Welcome to EuropeanaTech and AI. Today, joined by the Qurator project. And you see already our speakers who are going to present their research work in the Zoom participants list and here on your screen. Thank you so much that you dedicate your Friday afternoon to the series. I'm going to share some of the information that we have about the series with you now. And afterwards, we're going to listen to the presentations. So what is EuropeanaTech X AI all about? This is a webinar series that the EuropeanaTech community organizes together with the Europeana Foundation and the network. And we're exploring opportunities and challenges of working with artificial intelligence in the cultural heritage and arts sector. And if you are going to have a look at the site of EuropeanaTech and AI on Europeana Pro, you can find all kinds of information about the series and also the recordings of the first two sessions. To make this an enjoyable session for all of us, I'm going to share some housekeeping rules with all of you. So first note, this event is being recorded. So if you don't want to appear in the recording, please take off your camera and close your microphone. If you want to be sure that we can also identify you, if you ask questions, for example, or if you want us to get in touch with you later, check your username. And it's really helpful if you use your first and last name. And please mute your microphone when you aren't speaking. And if you don't, be aware that I might, or Tamara will mute your microphone. If you need to leave for a second, but you had your camera on, please turn it off. And you can use the chat to share your thoughts or comments, or even if you want to get in touch with other participants or exchange ideas, you can use the chat for that. But if you want to ask questions to the speakers, it's easiest for us if you post them in our Q&A document that I'm going to post in the chat in about a second. And we're going to pick up some of the questions directly in the document, and others we are going to answer in the Q&A at the end of the session. So we are also asking you to follow our code of conduct. And if you want to report something that you see as a breach to the code of conduct, you find all the information necessary to, in such a case in the code of conduct. And you find the link to the code of conduct also in the Q&A document. But let's get to the point. I'm really happy to welcome our speakers to this session. We're going to talk about the Qurator AI project based in Berlin. And I'm really happy to welcome Georg Rehm from DFKI. He's going to introduce us to Qurator and giving us a brief overview about the project and what they're working on. Stefan Grill from 3PC X Innovations is going to talk about semantic storytelling. Joachim Quantz from Art and Com is going to introduce us to the image garden, and I'm really intrigued by that title. And last but not least, a fellow member of the EuropeanaTech steering group from Berlin State Library is going to talk about Qurator and the library. So welcome everyone, and let's get to Qurator. Hi, Georg. You have to unmute yourself so that we can hear you.
Please be assured this is not my first Zoom call. Yeah, but it happens all the time.
We believe you.
So in the next, thanks, Larissa. For the next 10, maybe 11 minutes, I will give you a very brief overview of the Qurator project, which is funded by the German Ministry for Research and Education. So, it does work. Okay. So the first few words on the motivation and the need for intelligent content curation. We know, and you probably know this as well, that in all sectors and verticals, including GLAM, the demand for intelligent systems to support the processing of digital content is rapidly increasing. And we know this from really every sector, every customer, every collaborator we work with. There is a huge demand. In this specific case, in this specific project, we are looking at vast amounts of content. They are available, and there is a huge pressure everywhere, left, right, and center, to publish new content quickly, but also to make existing content available, which requires faster, more efficient, and smarter processing methods. This is, in a way, already the motivation for the project, which aims to develop a sustainable and innovative technology platform that provides services to support knowledge workers in various industries to address the challenges they face when curating digital content. There is a bit of lag here in the remote control. Does it work? Okay, no. So the main goals of the project, in addition to developing this technology platform, is to establish an ecosystem for curation technologies. We've been trying in a previous project to shape and position this emerging field since 2015 already. And to establish our region here, the metropolitan area, Berlin-Brandenburg, as a center of excellence for the development and industrial application of technologies for content curation. Here I want to specifically highlight that we are developing solutions for general curation technologies, for sector-specific curation technologies, and you will get some examples later. And we make use of language technologies, of AI and machine learning technologies. This is all related in some way or shape to natural language processing and to language technologies. Just as an indication here, the global market is predicted to reach an astonishing $42 billion in just a couple of years, which is astounding. And this number is growing with every new study that is being published. The project consists of 10 individual projects, which are worked on by the 10 different partners. Today with us, so the colleagues Joachim, Stefan, and Clemens, they will talk about their respective projects, which you can also see highlighted here on the screen. I will say a few words about the DFKI part in Qurator in a second, if the system lets me. Yes, it is. So the DFKI project is called a flexible AI platform for the adaptive analysis and creative generation of digital content. We are one of the technology partners in the project. So we build the technological foundations. And here on the slide, you can see a brief glimpse of our technology platform. Everything is based on managed Kubernetes, which runs on a infrastructure provided by a Berlin-based cloud provider, and we develop mainly these little boxes you can see on the right-hand side, these different services for pre-processing, for semantic analysis, or for content generation. And just like Stefan, he will attack the problems of semantic storytelling from a slightly more concrete angle. I will also talk about semantic storytelling. We are collaborating with 3PC or 3PC on this topic. If Zoom is changing the slide any day now. Yeah, can someone maybe just advance the slide? Because it doesn't work. Okay, thanks. So we are developing the base platform of the Qurator project with a number of different services and the whole platform. That's why you can see these different screens here. The platform supports the processing of textual content mostly. We are also working on multimedia content. Joachim will show a couple of additional examples from the Art and Com project. And this platform is so modular, so flexible that we can easily also make use of different processing services developed by the partners. And they can be integrated here. Yeah, I'm still having problems with the remote control. Here it is. Thank you for swapping the slide. So we are working on semantic storytelling the following way. What we want to do is develop is an approach, a technological approach for semantic storytelling. And then Stefan later on will show you what this can look like to the user under the hood. We are developing approaches, algorithms, technologies that are able, in this specific example, to take self-contained homogeneous text collections, but really huge collections. We know that they are about a certain topic, and that we can extract pieces and fragments of information that are related to each other in a specific way, and then re-aggregate and represent and restructure the information in a way that makes sense to the user. Here you can see a brief example. This is what our current mock-up of the story editor looks like, where someone like a journalist is working on a specific article, writing an article on the AEG turbine factory, for example, and then the system can extract from this document collection different pieces of information that are relevant to this topic, and that can also structure them and present them in a way that makes sense to users. This goes way beyond normal text summarization. This is semantically informed and rhetorically informed. We can't go into the details, but this is one aspect we are working on. Right. I said at the beginning that we want to, this is one of our goals, to establish the metropolitan area Berlin-Brandenburg as an international center of excellence for these kind of technologies. What can we do in order to reach this goal? I just wanted to briefly mention the European level here, or the Europeana level, if you will. So there are hundreds and hundreds of projects all around Europe. Some of them you can see on the screen. Some of them are international European projects like AI for EU, for example, which is building a European AI on demand platform on a very high and generic general level. ELG is another project that we are coordinating as DFKI. We are building now a EU-wide platform for the whole European language technology community. And in addition, Clemens helped me with the activities in Europeana. There's quite a bit going on in AI task force. There's a machine learning strategy being developed for Europeana, and there's an interesting project with an interesting name, which is also related to AI developments. I just wanted to do a quick dive into European Language Grid, just so that you know what this is. There is a sector called language technology or natural language processing, and this project here is developing a fairly big European cloud platform for the whole European language technology landscape, which by and large encompasses about 1,000 companies and about 600 to 700 research groups. Right now, they don't have a concrete umbrella platform, and we are establishing ELG as this big umbrella platform for the technologies that can also be used in Europeana, in other sectors, in the finance sector, in the legal sector. So this is supposed to be develop into a larger. The remote control doesn't work for me pretty well, so I'm trying to advance. Here it is. What we are trying to do is we are establishing this platform also as an umbrella for other projects, other outputs that people produce. Could be a PhD student who's developing a certain system for information extraction, for example, or for text summarization, or for larger projects that provide interesting research outputs. And what we are currently doing is we take all the different developments from Qurator, from many other projects, from many other companies, and we put them into the European Language Grid so that we can make them available on the European stage. Yeah, this is what it looks like. So there are pages for many projects, for many companies, for many research groups in ELG, in the European Language Grid. And then with the a few clicks, we can make them available and disseminate them throughout Europe, which is great. And we hope that this will contribute significantly to the success of the project. So what are our next steps? Last slide. We will continue, of course, the R&D work in the project, including evaluation and rapid prototyping. We in DFKI, we have an emphasis on basic curation services, semantic storytelling, workflows, and the platform development. Together with the partners, we are working on the different prototypes and showcases, including the colleagues who will present in a minute. And yeah, finally, we will hopefully integrate everything into ELG, into the European language grid, to make it available throughout Europe to many, many interested stakeholders, and also including Sorry?
No, I think someone was muted by me.
Okay, all right. Thanks so much. That was it from my side. Sorry about the technical hiccups.
Yeah, the need for intelligent system is big in this sector, as well as in presentations. Okay, thank you so much, Georg. And we're going to the next presentation. And Stefan?
Yes.
Does everything work from your side?
See if the remote controls work for me better. Okay.
I hope the power is with you. There is kind of a short lag of some seconds sometimes when you click on the next slide, and then it can take some seconds.
So, all right, I think it's
good. Great.
Okay. Thanks, Larissa, and hello, everyone. My name is Stefan Grill. I'm Director Innovation at 3PC. And in this role, I'm also responsible for the Qurator project at 3PC. But before I start my talk about semantic storytelling, let me give you some information and facts about our company. Next slide, see if it's working. Okay, here we go. Okay, this is our office in Berlin-Kreuzberg. So 3PC is a digital agency based in Berlin-Kreuzberg with more than 25 years of experience in digital communication. And it was founded 1995 by Armin Berger as one of the first internet companies in Germany. So you can say 3PC really is a pioneer of the internet. Actually, one of our first clients was the Berlin State Library, and somehow Armin managed to convince them in those days to have an internet or to have a website on the internet. So since then, 3PC has grown constantly, and now we are more than 90 people working there. And if one day the pandemic is over, so if you are in Berlin, you are invited to come to us and see our office. I think we have enough space. Okay, so next slide. All right, okay. So today we have a wide range of clients with a strong focus on politics, science, and cultural institutions, especially museums. And for our clients, we realize websites, mobile apps, and also other digital applications. So what do we think makes us special? In short, we always focus on the user. So our goal is to create a unified user experience for our clients and the users of our digital applications. That's why we have all the competencies we need within the companies that goes from strategy consulting, corporate design, and content creation to user interface design, content management, and software development, what we especially need in the Qurator project. So now let's turn to the main topic, semantic storytelling. I don't know if it's better to use the mouse or the... Okay. Okay, the first time we've implemented our idea of semantic storytelling on a website was when we created the so-called Stasi Mediatek, which you can see here. And there's also a link within the presentation, so you can probably check it out yourself. Stasi stands for Staatssicherheit, which used to be the secret service of the former German Democratic Republic. And as you can imagine, this archive contains many interesting and also tragic stories. So how can you tell these stories with files, documents, and reports that are not really exciting? That was the question when we started this project. And also, besides historians, who would like to go through all these files to find out more about the history of the GDR? So that's how we started this project. And our solution was to reach a broader audience. Our basic idea was to tell a story connecting original documents with short text that build together a storyline. From any point of the story, the system provides related content, giving background knowledge or referring to other relevant documents in the archive. It soon became clear for us that story writing and story editing in a huge archive is a complex task, especially when it's not only linear text with some images attached. Next slide is hopefully coming. So try it again. I'm sorry.
Tamara, could you jump in? Thanks.
Okay, so that's the reason why we ended up in the Qurator project, let's say. We decided to get involved in R&D project using semantic technologies and also machine learning to develop intelligent tools that support many tasks of knowledge workers and also authors. And in that role, we have this project, Interactive Storytelling. And that's what I want to tell you more about. I don't know why. Okay. This is a picture I guess you are quite familiar with. What we can see is digitized cultural heritage like handwritten letters, transcriptions, scans of graphics and paintings, or other images and photographs. And in order to realize semantic storytelling, our idea is to enrich these artifacts with semantic information, not only on a document level, but on the smallest possible level. We call it semantic unit, or Georg just called it semantic fragments. Unfortunately, we can't see it. That was kind of an animation. It's not starting. So points within this picture should be highlighted now. I guess it would have been easier just to share the screen. Sorry. Okay, now you can see it. So yeah, that was the idea, to enrich these artifacts with semantic information, not only on the document level, but also on a level of text, and also highlight objects within images and so on. So this could be smallest units for storytelling. Okay. These semantic units we call narrative units, and they give us the opportunity to formalize the semantic relations in nonlinear stories so that recommender systems can make use of it. Because this is one of the challenges you have. How can a machine give you the right recommendations on the way of a story? And so we need to kind of formalize what a story is. Unfortunately, I'm still having problems with, okay, next slide. So as part of our research, we then experimented with different types of stories and storylines. And doing this, we were able to understand the level of complexity that we have to reduce when developing tools for semantic storytelling. So what do we need if we want machines to support storytelling? The answer is semantic enrichment. Here's an example. On the input side, we have a painting from Hendrik Averkamp with the usual kind of metadata, like he's an artist, they have a title and the museum. And so What we do now is we use AI-based microservices to enrich this digital item with additional semantic information. That is, we use image classification to detect that it's a painting showing a scene outside. We use object detection to identify persons and objects. We use named entity recognition to classify existing keywords as places, organizations, and people. And finally, we use automated linking to useful background knowledge like geonames or Wikidata or any other vocabulary or ontology that is helpful for the use case. The result is an enriched content item that is semantically linked to other content data within an archive. Next slide. Okay. So basically, one of our main tasks in the Qurator project is to develop services for semantic analysis that we combine in pipelines, depending on the content we want to process. For example, if you look here, you can see OCR. So once the OCR is finished and you have the extracted text, your next step would be to do named entity recognition on the text and so on. So this is basically what we're doing, developing microservices for content enrichment. Is one big part of our project. But that's not the only thing we have to do when we want to do storytelling. You also have to focus on workflows, which is hopefully the next slide. Here we go. Keeping our goal of semantic storytelling in mind, we had a closer look on our research into the necessary workflows. In this workflow, tools for curation can be used on the left and also on the right side. On the left side, for the task of semantic analysis and enrichment, we can use intelligent tools that assist with tagging. And on the right side, when it comes to storytelling, we can make use of recommender systems to support the creation of nonlinear stories. So, last part of my talk is I want to show you two tools we've developed within the project. One is AI-based tagging. This is what you can see here. And the other one is supporting the creation and publishing of nonlinear stories with a special web-based editor, which I show you in a video. Okay, it's already the video. I have to go back, or I'm trying to go back. Okay. All right, AI-based tagging. So what we do here, we call it digital asset management or AI-based digital asset management. But basically, it's about providing the right user interfaces for semi-automated tagging of content. For example, here you can see we've got a picture. So the machine is recognizing persons and objects within these pictures, but you always have the chance to correct what the machine recommended or recognized on a picture or within a text or anything else. So in this logic, we always want the human in the loop. This kind of quality assurance is necessary to build recommender systems we can use in the editorial workflow of storytelling. And that is what I want to show you next in a hopefully short video. Okay, trying to start the video. So what you can see here is a conceptual study of our story editor. We've got kind of different versions from it. This is specialized for cultural heritage. So it wants to demonstrate how we integrate our AI-based services into a tool for storytelling. You can see how to create a new story. So the story editor user interface has two main areas. On the left side, you can see the so-called storyboard. This is where you can create story elements that can be semantically connected. And on the right side, you can see the content browser that allows you to search content you want to integrate into a story element. The content browser integrates our AI-based recommender system and supports the editor when searching for content. So if you have a look, probably it makes sense to go a little bit further. On the left side, can I? All right. So on the left side, where we have the storyboard, you can create story elements, and you can also combine images, with texts, and probably also interesting for you here is you can also integrate texts, which is automatically analyzed and linked to background knowledge, for example, Wikipedia, or also a glossary that you want to have on your own website or on your own application. So this is the way we want to integrate our services in this kind of editor. So the next step is to create semantic units within a story element. This is what you can see here now. You can highlight certain objects or areas within a picture, and then you can create semantic paths to other story elements, creating a nonlinear story. So this is, I think it makes sense to go to the end of the video, because this is going to be kind of, after a while, creating a story like this is going to be kind of complex in the end. So what you need is a kind of overview, and this is what I want to show you at the end of this animation. So here you can see that you also have a possibility, kind of special browser, to see the story you've created, and also the different connections and paths. It's a nonlinear story, so there are more paths, and you can also edit them and have a good overview. Okay, to conclude, we at 3PC, we are convinced that storytelling is a great format to get engaged with a broader audience that is interested in cultural heritage. And with curation technologies in semantic storytelling, digital archives can become more than just a searchable collection. So if you are interested, don't hesitate to get in touch with me. We are constantly looking for pilot projects and use cases. So it would be great to try out new material and see what we can do with storytelling. Thanks a lot.
Thank you. And I think there's a short question that I'm going to ask right now, Stefan. In the chat, someone has asked if it's the final product of the Troubadour project. Does that ring a bell with you?
No, because I don't know it. I don't know the Troubadour project. This is just a conceptual study from our designers, to be honest. So there's no real semantics in it, right? We just wanted to show what's possible.
Oh, great.
Probably it makes sense if this person can write to me, and it would be great for us, you know, to get to know this project.
Great. Thank you so much, Stefan. And then next up on our virtual stage here is Joachim. Are you there? I can't see you right now.
Hello.
Oh, great.
I'm trying to get the control. Let me briefly introduce myself, Joachim Quanz. I work for Art+com as the head of research. And before I worked there, I worked on natural language processing and knowledge representation in the 80s and 90s. So my personal background is computer science, but also linguistics and philosophy. And I have to apologize that I didn't really prepare slides, but rather will present you some images from our internal wiki system. And also I want to explain why we are doing what we are doing. So Art+com usually works for museums or showrooms. And what we do is really exhibition design. And that means that our projects can run for 3 or 4 years. Sometimes the museum is built while we do the exhibition design, and it covers a wide range of possible topics. So for example, one of the last things we have done is the Qurator Museum in Berlin. It's a museum about the future, or what they like to say about the possible futures. It can also be something like here, migration, bird migration, that's in Denmark, I think. Or before that, we worked on the Royal Yelling Center, which is about Vikings, or for Amsterdam for Micropia, which basically means that we work on projects like these for 2 or 3 years, and we need to understand what is the content the museum wants to show, and how best can we present the content to an audience, and how can we use media to do that. So in the project which has been mentioned before, digitale Kuratierungstechnologien, digital curation technologies, we focused on how can we get information out of a text with entity extraction, and then show it in a Wikidata map. And we've continued in this project in Qurator with the idea of showing a huge collection of images and giving users interactive user interfaces to interact with these visualizations. And that is basically what we call Image Garden. I could try to give you an explanation of the name, but the name comes from an artist working at Art+Com. So at Art+Com, we have not only computer scientists, but a lot of designers and artists. And Simon Beckert, who created this Image Garden, has some ideas why you should call it an Image Garden, having to do with gardeners and reading and a variety of objects which you can arrange, etc. So the basic idea is to take a huge collection of images, have an image clustering, and then a UMAP representation in 2 or 3D space, which allows you to view the collection as a whole and then identify clusters in the collection. And that is something which can be useful on several levels, and I will explain how this can be useful. So this is the first step, what we did. And then we thought that since we started with plant drawings, that it would be nice to draw something, a line, and then search for images or plant images where this line is shown. So I will give you briefly an overview of the process pipeline we have implemented. And I should be clear, this is really technology exploration. So we are doing prototype spikes, but it's not an integrated tool. It's for us, it's really to see, are there technologies in AI, machine learning, etc., out there which we can use and which we can put into user interfaces to make them usable to knowledge workers or visitors in a museum. So we are not focusing on the AI aspect. We think that other people are really good in developing these AI algorithms. It's more for us to take these and integrate them into our tools. So basically the idea is you have a huge data set of images. What you first have to do is you have to do some pre-processing. For example, some of the images might be big, others are smaller. So it's usually a good idea to have them all in the same size and maybe to clip away information which is not really relevant, etc. Then we run image clustering and UMAP, and then we get these kind of nice visualizations. Let me see whether I can show you some which is more interesting. No. So like these, so they can be really huge. And then we have possibilities to interact with these visualizations by zooming in, by filtering, by sorting. This is done usually by taking just the image as itself, but there's also metadata involved. So you can also do the clustering with metadata combined with images, or you can do something like give me a timeline of the objects in there or locate them on a map, etc. What I will focus on now is more the other steps, namely trying to get the edges and ridges out of the images, and then having lines drawing where you can search in there. In general, the whole idea of this is to have the items in a collection somehow being related to each other and also being related to real world objects, events, person, etc. So whenever we show our spikes and prototypes to curators, usually what they like a lot is that they say, so I can get an overview over my collection. And the second thing is, and I can relate the objects in my collection to events having taken place at a certain time or persons being involved with these objects. So that is what makes it a lot more interesting than the existing digitization. Let me show you. We are working together with the Museum for Naturkunde, Natural History or Science in Berlin. And of course, they have a huge collection of items. So some of them they can show. This is the skeletons of saurians, etc., or other nice things. And lots of things they can't show because they are somewhere else. And they have, I think, 30 million objects. And definitely they can't show all of them. But of course, they're doing some kind of digitization right now. And most museums offer some kind of access to their digital content by having this kind of search interface. It's like Google, you type in a keyword and then you get all the results, which is not bad. But all these results are isolated in a sense. So you can see here, and of course you get the result list and you see, everything is the same, it's opal. So there is a relation, but you can't really see what is the connection between this opal maybe and this, or between some other mineral. And that's basically what we are trying to achieve with Image Garden. So to have something where you can really understand the collection and then interact with the collection. It can be used in 2 or 3 different application scenarios. So when we started, we thought we'd build these tools for our knowledge workers. So for example, if we get a collection of images from a client, we can look at it and we can better understand, okay, what are the relevant clusters? What are maybe things we don't really need? Or how can we relate certain objects? We then realized when showing it to curators, the curators were really interested. So they said, yeah, that's exactly what we need. We want to show what the relation between our objects is to real world. We want to tell stories. That is, we want to not only present objects individually, but tell stories about them. So they got interested. And right now we are thinking about using these interfaces also in exhibits in a museum, so that visitors can really access the whole collection in some kind of interactive exhibit. That's something we're working on right now. So we hope that we will have results at the end of the year, but I can't promise that yet. So let me briefly show you in the end some videos explaining how this second part works. So this is a visualization of, I think, 2,000 plant drawings, and you can draw a line which doesn't really connect to the whole collection. And then we look for images which have these lines in there, and you can refine them in the overview, etc. And in the end, what we do also is something, a latent walk where you can go from one image to the other, which is really nice in the context of these plant drawings. Maybe it's not that interesting with minerals or with other material. So the pipeline I've shown before is something we have tested with different data sets. So we have tested with data sets of around 10,000 objects. That's, for example, one museum in Berlin for which we are developing an exhibit right now. They have about 10,000 images, up to 500,000. So like I said, in the Museum for Naturkunde in Berlin, it would be 30 million objects. I think that would probably blow the system up, but you can probably separate it in different issues. Training the UMAP with 500,000 images takes about 3 days right now. So what we have achieved so far is when we get a collection, and to be honest, the most difficult part is to convince the client to give us all these data. That usually can take weeks or months, or even doesn't work at all. But in principle, once we get the data, which can be 10, 20 gigabyte, whatever. So if we have that at art+com, then it takes us about 1 week to work with the data, to do some pre-processing, to do the training, etc., and then present the Image Garden pipeline. And from my point of view, 1 week is really, really nice. So we had one example where a museum said, yeah, you want to work for us? And we said, yeah, by the way, we can show you what we are doing in a research project. We just need your image data. And so 2 weeks ago, we could present their collection, and I think for them, it was the first time that they had an overview over their collection. So when we talked to them, they said something like, yeah, most of the images are black and white. And then we said, yeah, how many? We don't know. So this is a really nice tool for curators to get a first feel for their collection, to get some clustering, which gives them ideas how to arrange them maybe in an exhibit. And we're quite confident that at the end of the year, we will have 2 showcases with the Berlin Museum and the Museum for Naturkunde, where we can really show how Image Garden can be used in curating collections and also in designing smart exhibitions. Okay, that's it. Thank you.
Thank you so much, Joachim. That was really interesting to see how Image Garden works for institutions. And we stay in Berlin, as with all these presentations, and head over to the Berlin State Library. Hi, Clemens.
Yeah, so now it's me who is having the Zoom issues, because now the menu option to claim the, now here it is, okay. Right. So let me take remote control. Yeah, I hope you can see the slides now. Yeah, so thank you, Larissa. Thank you also to the colleagues. I'm now going to present the Qurator project, how it's implemented in the Berlin State Library. And yeah, so in order to leverage really the potential of these language technologies, these smart systems that Georg presented, to make the content really usable for this semantic storytelling or for such exploitation as we've just seen. Well, first we need to do some digitization, obviously. And the main goal of the Berlin State Library in the Qurator project is really to support our ongoing digitization pipelines and really boost them with the potential that we see in AI and in machine learning. So I'm gonna, oops. Well, I'm also struggling with the remote, so yeah. So yeah.
No, you just have to be a bit, you just have to wait like 2 seconds. It's not more like than that.
I will be exercising more patience. Yeah, so but just a short background maybe about where I work. So I work as a research coordinator or research advisor at the Berlin State Library. Which is one of the largest libraries in Germany. We have about 25 million media objects and already 2.5 petabytes in our digital assets. And it's quite a unique concept also. The Berlin State Library forms part of a larger, one of the largest European cultural heritage entities, the Prussian Heritage Foundation, the Stiftung Preußische Kulturbesitz, which includes also a number of museums, an archive, and various research institutes. Historically, as things are in Berlin, we are a library in 2 sites. So on the top, you can see the historical building of the Berlin State Library Unter den Linden, which has just been reopened. And now I hear also from 2 weeks from today will be again accessible to the public. So after 15 years and hopefully now the downfall of the Corona pandemic, you will be able now to enter into the reading rooms again from mid-June and really explore this renovated new building. I work in what was used to be the Western Berlin Library at Potsdamer Platz, also very intriguing architecture by Hans Scharoun. If you're ever there, I really recommend visiting. So yeah, we do a lot of in-house digitization of our collections. We have established an in-house scanning center where we operate in 2 shifts with about 20 highly specialized scanning and capture devices. We have an annual production of about 2 million pages or images per year. And what's quite nice, so you can explore all these digitized objects in our digital collections. Currently, around 180,000 objects can be found there. And we have a very nice policy that all the publications that were published before the 1920, we assign a public domain license. So you're free to download them, reuse them, remix them in any way that you can think of. Right, so I'm patiently waiting for the next screen. That was a bit too much. Okay, here we go. So yeah, as you've seen in the introduction by Georg Rehm, there's a total of 10 projects within Qurator, and the Berlin State Library is responsible for the sub-project 10, AI for digitized cultural heritage, and I've just mentioned that in the introduction. Our main aim is really to significantly improve the quality and efficiency of digitization by really supporting the process with state-of-the-art AI technologies in all steps. We develop software that we release as open source. You can find everything on our GitHub. We also publish various data sets. So for example, we extracted about 600,000 graphical elements from our digitized collections that could be, for example, also used as input data for the image garden experiment that Joachim presented. You can download that from Zenodo. It's about 170 gigabytes. We have trained various language and computer vision models that we released publicly. And on the Qurator website, you can also find a few showcases, which are recordings of some of the technologies. Unfortunately, only in German at the moment. And 21, 22, 23. Move. Okay, here we are. So yeah, one of the first steps in the document digitization is image pre-processing, image optimization. And one thing that needs to happen there is binarization, which means that any digitized page or document is converted internally into a pure black and white image, which significantly boosts the performance of the subsequent processes that analyze these image data, simply because it helps to improve the contrast between the background, here the paper, or any artificial artifacts introduced, like here you see an example ink from the adjacent page shining through and disturbing the clarity. And thanks to our binarization, which we trained on an autoencoder model, we have now been able to get a very good distinction between foreground and background, as you can see on the right image, which helps significantly reduce the noise in, for example, then the layout detection and the actual recognition of these texts. Also here you can find everywhere the link to the according programs on GitHub. We release everything under an Apache license, so you're free to reuse this also in commercial contexts. And that was still not long enough for the slides to move. So here we go. Yes, so once we have these images pre-processed and optimized, the next steps that follows is the document layout analysis. So here the task is basically to detect the various components that the page is constructed from, say, for example, headers, paragraphs with text, image content, separators, and then various more granular categories of these types. We here followed an approach that is state-of-the-art in document image analysis at the moment, using a combination of a ResNet 50 with a UNet for encoder and decoder. And basically we follow here an approach which is called pixel-wise segmentation. So that means that individual pixels are classified by the neural network and then subsequently combined into larger connected components, which then form the individual regions. You see here on the left two examples of the results for the detection of the text regions and then of individual lines within these text regions. First on the left with our initial iteration of this tool, which was a pure machine learning driven approach. And we saw that we encountered some issues there, not properly detecting all components very well. So we decided to supplement this approach with some additional heuristics. So combining the data-driven approach with some rule-based methods. So for example, based on the headers or separators detected in the layout analysis, which you can see in the right images, significantly helps us to boost the accuracy of the region and text line detection. So right, go to the next slide. Yes, so a byproduct, which is also quite nice, and I've also already briefly mentioned this, is that as part of this layout analysis, we actually also get the information about any regions with their pixel coordinates on the image, on the document that contain some form of graphics. And using this information, we can extrain these graphics and, for example, train an image classification model. In this case, we used ImageNet to determine the similarity between the images based on their features, which then allows us to do some image search or image similarity search. So, for example, you see here in this image you can upload this document with the elephant, and then the system will retrieve images with similar content on them. And we also implemented here an additional object detection step using the YOLO implementation, which then allows us to select a region of interest within the image. It's not shown here, but you could, for example, in the image here with the elephant, select one of these birds, and then the system will be only looking for this bird type element within the image. So the nice thing is that, as also what Joachim already showed, this really provides an alternative a kind of browse and entry point into a collection, which can be very nice to play around with and to explore it from a different angle. So the next slide will be here briefly. Yes. So now that we have analyzed the layout and the graphics, of course, the core goal of this process is to really generate high accurate electronic text. And traditionally, there have been some issues with this, especially for the in Germany and German-speaking countries, very prominent Fraktur or broken fonts. And also here, we benefit from recent advances in machine learning and deep learning by applying a new OCR engine, Calamari, that we trained on a publicly available data set of OCR ground truth, GT for HIST OCR. And you can see here a snippet of an historical newspaper, and on the right side, the recognized text. And while I've now actually determined that there are still, I think, 2 or 3 errors in there, you will see that it's a very high quality and accuracy, and the OCR even correctly detects the Unicode code points, for example, for the traditional long S, which is a character which is often confused with the F in Old German. A nice added benefit here is that we can apply a single generic and language independent OCR model for all documents, even if they contain a mixed form of Antiqua fonts and Fraktur fonts. And in our initial evaluations, we've seen that this really allows us to reduce the error rate in the documents from about 20% down to about 2%, which really opens up the potential then for some new smart and content-based enrichment. And we're gonna see that on the next slide. Oh yeah, well, I forgot about this one. So actually, like I've just said, there can still be a few errors remaining, and then there's been traditionally the task of OCR post-correction, which often used lexicon-based methods, where you try to check OCR errors against the dictionary, often frequency-based. The problem of that approach being that for historical languages, there can occur some spelling variation, and there are not really sufficiently specific language resources and lexica for these historical variants. Plus, it is very hard if the error rate of the OCR is already very low to still improve that with a pure frequency-based lexicon approach. So instead, we try to formulate the problem of error correction as a machine translation problem, where we basically trained a sequence-to-sequence model on a large corpus from the Deutsches Textarchiv, which contains transcriptions, highly accurate and quality-controlled transcriptions for about 4,000 documents in historical German. We OCR'd these documents with our current OCR model, and then basically we trained the machine translation model to translate the erroneous OCR text back into the correct originals, and thereby train the model to autocorrect such OCR errors. And we see that it actually works. So we achieve a relative improvement of about 18% with this, which is quite good, especially given the fact that we hardly introduce any new errors into the historical text, which is always a challenge. Right, so trying to catch up a bit on time while I'm waiting here on the next slide to fly in. Yes, exactly. So now that we have highly accurate text, we can really use the full potential of natural language processing. For example, very often requested from users is named entity recognition, which allows us here in this case to identify the names of persons, locations, or organizations that occur in the OCR text. We herefore trained a model for historical and contemporary German based on the BERT transformer architecture from Google, which we first trained unsupervised on about 2.5 million pages of historical German from our digitized collections. And then we did a supervised training with modern and historical NER gold standard data. And we did a cross-fold validation of this, which shows that our results are really competitive with the state of the art for historical German NER, with an F1 score of about 85.6%. Now, one thing that is really beneficial once you have detected these named entities is to also disambiguate them, because they can be ambiguous. And I will show an example here in just a bit. Yes. So common example here is the sentence Paris is in France. Well, this could have at least multiple meanings, referring by Paris to the city in France, or also to, for example, a person like Paris Hilton. So it is really useful in this stage to uniquely identify the particular entity that is being spoken of in the text. And for this, we use also a BERT-based approach, which basically determines the semantic similarity of the entity found in the digitized document based on the context of it and the context of entities under that lemma in Wikipedia. So basically, we constructed a knowledge base harvesting Wikipedia for those categories, and trained an embeddings model on these Wikipedia article texts, which then is supplied to a second BERT model, which takes a decision for any given entity that we determine to be in an OCR, whether it is similar to, which is the most similar lemma from the Wikipedia knowledge base. And based on this, we enrich the full texts where entities are found with links to the according entries in Wikidata. And for toponyms, we also enrich them with geocoordinates, which then subsequently should allow new possibilities again for retrieval. And I think I have one more slide, maybe two. Yeah, I think it's two. Yes. So I think I still remember one of the colleagues we hired for the Qurator project in the beginning, when he mentioned he has never done a machine learning project without building a custom annotation platform. So eventually we also came up with our specific data annotation tool here, which we call NEAT, the named entity annotation tool. It was really conceived to be as simple as possible tool with a high accessibility and no demands on installation or specific rights, because we really want to roll this out within the library, which has a fairly restrictive IT policy. So it's implemented as a purely JavaScript application. So you basically have one HTML file that you open in your browser, and then you can work with it. It is fed by texts in a simple tab-separated value format that is based on the format used in named entity recognition competitions. And it allows then the user to either correct or add the named entities tags, and supports them by showing some snippets of the documents that are being annotated through a IIIF image API integration. And recently, with many of our colleagues being sent to the home office, there was a huge demand in the library for alternative tasks that people can carry out from home. So we made a brief change to this tool, which then now allows it also to be used for OCR correction or transcription purposes. We have used it now with a number of colleagues who've transcribed documents using needs, so that we can use these as ground truth. And last but not least, a brief outlook on future work. Oops. So here we go. One of the next steps that we're very keen on now that the Qurator project will come to an end this year is really to apply all these new techniques to the collections of the Berlin State Library, which in turn then will give us again a large set of really much better quality data to work with, to create better models, to create better services. But yeah, at the same time, we need to be aware that our quite powerful server is not really still powerful enough to run through these 2.5 petabytes easily. So that would take years. So we really need to think about ways to scale this approach, and ideally without sacrificing any performance. At the same time, we're looking at some new possibilities to integrate computer vision and natural language processing techniques in a holistic document understanding system, which should be mutually beneficial. And we are also having plans to transfer these developments, especially to other languages and scripts. We have a very large East Asian collection in the Berlin State Library, so we want to see how well these techniques can be applied to, for example, Asian documents with complex layouts. And finally, all the prototypes and demos will also soon be available via our Berlin State Library Lab. And with that, I conclude, and yeah, I'd like to thank you very much for the attention, and yeah, open the floor to your questions. Thanks.
Thank you very much, everyone, for these intriguing presentations. It was really exciting to see how Qurator has been working during the last years. And we have collected quite some questions in the Q&A document, some more focused on details, some more about the whole project. And I'm going to start with a question actually that came to my mind, because I'm really curious about that one, because it was also a common point both in your presentation, Clemens, and in yours, Joachim. And just one question, Tamara, could you stop sharing this the presentation so that we can see all of us? Great. Both you, Clemens, mentioned that open licenses have been really important in your work to develop a project or making a project possible like Qurator. And Joachim, you mentioned that it's really hard actually to get all the data that you need to train models like that. Could you elaborate on that point a bit?
I can start, and then probably everybody can share in. So my experience is that usually what I try to explain is we would like to have data to toy around with it and to get some ideas. And usually the first answer is, yeah, no problem. And then when we really want to get the data, we encounter lots of problems. Usually it has to do that they are not sure whether they can give the data away or they don't want to give the data away. And very often the answer is, wow, this data is not really good quality. We can't hand that out, which is really making a hen and egg problem, because what we are saying is give us the data and then we can give you some feedback whether it's good or not, or how you could improve it. So it's really on very different levels. It has to do with probably copyright issues. It has to do with quality. It has to do with power. So people having these data, they have a powerful position in their institutions usually. So sometimes it's only one or two people who know the commands to access data, etc. And for them, it's obviously a nightmare to give that to somebody else. Yeah, but maybe others have other experience, but that is a recurring experience. So we're always very happy if we get hands on our data, and then usually we have to promise not to show it to anybody else, but that's okay for our research purpose.
Yeah, if I can maybe add a little bit to that. So yeah, thanks for really rolling out the red carpet there, Joachim. I think this is still a situation that is probably a common in some GLAM organizations, but we've really seen also thanks to the advocacy of Europeana, for example, with the rights statements movement, we've really seen some good progress towards opening up these collections. And I think there is a big potential, especially in these cultural collections, and making them more available in more suitable ways for AI and machine learning, because we see, for example, many of these data sets that are used by industry are, for example, trained for face recognition on images harvested from Flickr, where people did never give any permissions. So there's obviously some issues there. Furthermore, but just I think what is quite nice, what Joachim hinted at. So, for example, this is exactly what we want to promote with our library lab. So to provide really good documentation, for example, of APIs and interfaces, how to get access to our data, especially in those cases where it is really under a public domain license or even a CC license that allows for such reuse. And so that there is not just maybe one or two people in the IT department that know how to get access, but that this is really transparent and also attractive and easy for others to reuse. Similarly, we're also trying, for example, I've mentioned these illustrations that we extracted from our digitized documents. This is not normally something that we in a library would publish as part of as a collection item in our catalog of books, for example. So we need alternative platforms where we can make also such derived data sets, for example, or the ground truth that we create in such projects, the labeled data, available to the public and to AI and ML researchers. And also this is one of the aims that we try to support with our lab. And eventually this, of course, has the nice effect then that others come up with maybe better ideas than we have, how to give better access or improve the quality of this data. So I think, yeah, there's definitely great potential there.
Thank you. We're going to head to the next questions, and there are quite a few people interested in how they can actually interact with your project. So one question was if people could add their project to the project platform, or if I guess if they could reuse tools that you've shared.
This is one for me, I guess. The CH project platform. CH is for cultural heritage, I guess. What I showed was the European Language Grid. European Language Grid is a project or a platform rather that combines resources and services and data sets, as explained just now by Clemens and others, for language technology development. Yeah, so it's not about cultural heritage per se, but maybe what Cedric has in mind fits the bill. So please have a look. The address is EuropeanLanguageGrid.eu. What you will find there is in a way, the project website. The actual ELG grid is at live.europeanlanguagegrid.eu. I will paste the URL in here. Someone just did. Okay, and then the other one is will be down below in a minute. So this is it, yeah. So please have a look. If it's relevant for you, if it's interesting, then we are happy to have you.
Great, thank you. From Belgium, we had a question on, is everything developed from scratch? And if yes, on the basis of which training data? If not, can I find somewhere which software has been reused, for example, for everything that has to do with object detection and object recognition? So training data, yes, no, or have you reused other software's parts?
I mean, I probably can give an answer. So yes, we have training data, but not that much. We've got, we're facing the same problems like Joachim just explained. But we have some training data from a photo agency with the very diverse material of photos, images. So what we are trying to do at the moment is image classification, but we still don't know if it's enough or images we have. So we are still working with the collection, but probably can also ask the questions because I recently read a blog post or an article from the Europeana project that says we have got an API it's a pilot project for image classification, and we could probably make use of an API to extract the classes and also the images. I will post it into the chat and see if someone knows it and can tell me more about it, because I'm not a software developer and I just passed it to one of our machine learning experts to have a look, but he hasn't answered yet. So I posted here.
And there Antoine Isaac appears.
I was just going to say, do we have Antoine? Yeah.
That was the point where Antoine hops in. I think you also,
Okay.
if you're interested in that part, you can also look at the first session of EuropeanaTech and AI, where we were joined by the St. George on a Bike project, which has also been partly talking about this issue. But Antoine.
Yeah, I'm gonna be very short. This is a pilot indeed. This is about trying to use the Europeana API to source some of the data for the labels that we're interested in, because we try to complement some enrichments that have already based on metadata with some computer vision. So it's a bit like a different pipeline than the one that you have presented, Stefan, but there could be some connections. And actually, I had some questions myself about training and evaluation, and I guess you've answered them. But we should probably be in touch. And I'm not and this pilot is done by a member of my team, but I'm not the one working on it. So I would really prefer to involve him. So, and if you've got some colleagues on your side, then yes, please let's start a conversation about that, because we are trying to solve very similar issues.
Yeah, that would be great, actually, because what I can say about the models, as I said, I'm not a technician, but my machine learning expert, sometimes he's just using existing models, playing around with them, and then he's modifying them. And he's using convolutional neural networks and so on, but I just don't have the knowledge. So it would be great, somehow to talk about your ideas and see how far we can get, right?
And that's why we have EuropeanaTech and AI to actually make these networks work. So actually, this is a great point in time where I can also share that we're going to have a networking event as a last event for EuropeanaTech and AI as a webinar series that will exclusively make these kind of conversations possible. But we're going to head over to the next question, because I want to raise up some other questions asked. There was one question that I found quite interesting, because I think we touched upon this issue also in the first session. Would you say that these programs overall work best with 2D images, such as paintings, text, etc.? What about images recording architecture, fashion, or craft?
I can start by giving one answer, but it's a very specific one. For the image garden, basically, where we really don't, at the moment, we don't try to detect the objects or to understand what's in there. It's just the similarity of images. My feeling right now is, if the clusters, or if you have images which really fall into clusters humans can also understand. For example, if we have the museum collections, we have a huge collection of shoes, so it's all images of shoes. To find this similarity is not very difficult. But if everything is a shoe, then of course it's getting more difficult. So it really depends on the underlying data set. If it's very homogeneous, yeah, then it works best, of course, with 2D photos probably. But you can also, if you have architecture in there and they are somehow separable, then that works as well. So in general, I think there's no restriction to images or 2D or 3D. It's more difficult with moving images. I think that was a follow-up question as well. So we never touched moving images. We did some action detection and pose detection, but from my understanding, these work on individual frames. So you have just one frame where you can detect a pose, and then you check whether it's in the next frame as well, etc. It's not really understanding a sequence of images, but it's more image frame based.
Thank you. Another question to Georg. Could you tell a bit more about the semantic layer of your knowledge graph? How does the system deal and combine the source data sets?
With regard to what I presented earlier, that will hopefully turn into an actual knowledge graph eventually. I'm just rereading the question. Yeah, the source data sets. Yeah, the source data sets are actually source documents. So what we are trying to do is process documents, and these are documents of which we know that they deal with the same topic, but they are written by different people. Yeah. So, and what we are trying to achieve is to extract those pieces. Stefan calls them narrative units or discourse units or elementary discourse units. There are various names that all means the same. So we want to extract the individual atomic pieces of meaning in these documents and then recombine them in such a way that they make sense to the reader. So for people who know a bit about linguistics and text linguistics, this is blasphemy, because the usual notion is that this is not possible. Yeah, so you have a piece of coherent text that was written by one person, by one author, one communicator, and then trying even the thought about recombining things written by different people with different communicative purposes. This is not possible. We are trying to do this, this is quite ambitious. It's fairly avant-garde when compared to other established tasks, like Clemens talked about named entity recognition, which is one of the most established tasks. We've been working on this for decades. We know how to do it. It's also fairly simple, detecting individual names in documents, and then you're done. This now goes into the territory of actual natural language understanding. So understanding the meaning of a textual document is a slightly different ballgame than just identifying names in documents. Yeah, so we are trying to push the technology quite a bit here, and we will keep you posted. So.
Thank you so much. I've taken the freedom to answer one of the questions about funding. And as far as I know, Qurator has been funded by the German Federal Ministry for Research and Education. And I think Georg also told a bit about the general context in Germany for AI and how this fits quite into the agenda. So I think we don't have to go on right now about this topic. Otherwise, I think we are quite settled with all the questions. There's one last thing about private collections, and that question goes right to Clemens. Would this practice help digitize and integrate private collections that could this way be accessible as part of the library's collection while remaining privately owned?
Yeah, I was looking at that question before, but I'm not entirely sure what kind of process it's referring to. I think the main issue here is, which also connects back to what I said earlier, for example, with the labs, that there is not currently, at least in most libraries in Europe that I know, that kind of position of, say, like a data librarian or such, which would really be available to support such tasks, for example, accepting data from external contributors, managing, for example, contributions of annotations or corrections of the data. So this is something that has been often and rightfully desired from users. How can we actually also contribute data to you, or how can we support in the improving the quality of the data held in digitized collections? It's besides some simple hindrances that need to be sorted out with regards to the process. How is here communication managed? How is quality control managed? really, I think currently still a major and most of all an issue of there not being such resources or positions that could really support these kinds of activities in libraries.
Thank you. Joachim, do you want to add something?
Yes. So this is a very subjective view of our experience at Art+Com. In general, what I mentioned before is that museums are digitizing their objects, but many museums are really focusing on displaying objects in their physical space, and often digitization is done by a completely different department. And there's no real connection. And in general, we have the challenge that sometimes museums don't like technology or media, new media, because they say it's taking the attention away of visitors from the objects and going into the media. So very often we really have to convince them that in addition to the nice exhibitions, it would also nice to have something for visitors to look at before or after the visit. And then they may say, no, that's dangerous, because then they look at the website and why should they then come visit us? So there's a real, I think there's a real challenge of handling these two different aspects. And interestingly, Corona has changed a lot, because right now people can't come to the museum. So all the museums start thinking about, so what can we do to show our objects and exhibits in a digital way? So they are opening up. But it's really, from my point of view, it's really a constant struggle, and probably each museum has a different position on how to handle that. But from the computer science view, or maybe probably Europeana view, of course, what you would like to have is linked data, everything accessible from everywhere and combinable, but it's a long way to go.
Context, this example is well known. I think it was also a study published by the Rijksmuseum that actually showed that the attractiveness of the digital offerings of a museum actually helps to bring more people also into the physical space. So there's good evidence of that.
And I think Joachim's last words were kind of great to end the session as well. A constant struggle. This is what glam worlds look like. I'm really happy that we have had this session on Qurator. I think it was a great insight into your project and what you're working on. And from the many questions that we got in the Q&A document, I think that many people in this room also found it inspiring. So thank you very much for joining us for this third session of EuropeanaTech and AI. We are having more events lined up, so check out the events page on Europeana Pro regularly. You're going to receive also a thank you and participation note after this webinar from Eventbrite, and we're going to include the link to the recording there. Otherwise, join the EuropeanaTech community to be involved in projects or communities like these in the future. We wish you a nice weekend and hope to see you soon again. Stay safe. Thank you.